My name is Mark Foltz. I'm a software engineer on Chrome Media, and I'm going to just kind of posit a question. Are pixels better than links? Explain what I mean a little bit. So in the beginning, if you wanted to share a web page with someone else, we had URLs. URLs were great. I've lost count of the number of times I've copied from the address bar and pasted it into somewhere else, an email, social media post, what have you. Certainly still a dominant way that you can share something on the web with someone else. And we've had lots of innovations. We have URL shortening. We have QR codes, so now you can put them in the physical world and use your camera to get a URL, and browser features, so you don't even have to copy and paste. You can, with one click, you can send it to a nearby device. But these are all fundamentally based on passing a URL, a pointer to some content, which the person receiving it has to basically browse to their own copy of the page. If you want to kind of do real-time sharing, share a page with someone else and collaborate with it at the same time, again, we kind of started out with text chat. This is the early version of Google Talk, and URLs worked okay for that too. But you couldn't really collaborate in real time over the content. Each person you're chatting with would end up with their own copy of the page. There wasn't a shared experience. If you did something on the page or browsed or scrolled or navigated, other people wouldn't see that. So it wasn't quite where we wanted to get to in terms of real-time sharing. The next big evolution was WebRTC. This is an early version of Google Hangouts where we announced screen sharing. You can now actually view the same screen in real time, and that enables true collaboration and interactivity. If I do something on the web page that I'm screen sharing, then everyone else can see it too, and we can talk about it, work together on a document or something. But for web pages in particular, I don't think the mechanism, which is capturing your entire screen or desktop, is really ideal. It includes less relevant information like the browser window. It may include other windows on your desktop. Other applications or notifications might show up, and that's not something you really want to share. So kind of can we continue to do better here? We finally, in 2012, no, in 2018, we launched Get Display Media, and that standardized screen capture for the web and made it available to all web applications. Now, again, so you can use desktop and window capture and sharing to share web pages. It's usually better from a privacy point of view to give the users additional control over what's shared. So with Get Display Media, we were able to actually provide tab capture to the web. It was started as an extension API that was actually built to support casting your tab to devices like Chromecast in 2013, but it took a few years again, and with the development of Get Display Media to expose it to other applications like video conferencing applications like Google Meet. But it was really a big step forward. Now users can share just what's in the viewport of a single tab and not ignore everything else on their desktop, ignore other tabs. And since Chrome is responsible for rendering what's in that tab, it's possible both to implement capture in a much more efficient way than having to go ask the system to do it, and to customize what's captured. And those are a couple of things I'm going to talk a little bit more about, some of the work that's been going on in the last year or two to really make tab capture a more efficient and focused way for people to share web content in real time. And the way I see things headed is the ability to share more focused and meaningful parts of the web content in real time versus my entire screen or window or even entire tab. I call this semantic sharing because now the content can actually tell us, here's the important thing on the page that should be shared with everyone on the video call or in the live stream, and what makes the most sense in the current application context. And in this scenario, for example, we have a web page that has both a video conferencing app and a document, and we only really want the document to be shared into that video conference. We don't really care about the editing or the video tab strip or anything else. And we've been working over the last couple of years to add some of these capabilities to the web. The big step forward is a feature we call region capture. And this might play. Okay. We launched this in milestone 104, And it starts with the basic idea of tab capture, where the user selects a tab, the application requesting the capture gets a stream of frames. But now the page being captured can say only the content inside this element is really what's interesting to be shared. So the element, the page that's being captured tags a specific element on its page with a new API. We call that the crop target. And in this case, the div that says drag me that's getting moved around becomes the crop target. And the media stream that's being played back in the upper right gets cropped according to wherever that div happens to be on the page. So this works well for scenarios like the one I showed on the previous slide, where you maybe have a document that has some content that really needs to be captured and shared and other content that's not relevant. Originally, we shipped this only allowing cropping to divs and frames, but recently we've landed some work to enable cropping to any element on the page. So as long as we can get a bounds for that element, we can use it to crop the tab capture stream. I'm going to go a little bit into the details of how region capture works. It's really a two-step process. So first, the document that's being captured tells us, okay, what is the area on the document that's really interesting to capture? And it does that by grabbing an element from the page, say in script, and creating a crop and assigning a crop target to that element. The crop target is basically a wrapper around a unique token. It's serializable, so it can get passed either between frames through post message or maybe stored in local storage. And behind the scenes, the renderer that's rendering the captured document sends an IPC to the browser, and it remembers that this crop ID was generated for this particular tab or web contents. After the captured document has assigned a crop ID, we start capturing data about where the element, the bounds of the element, and where that is on the page. So every time that element changes position or is laid out, we grab something we call region capture data. We pass that along through Blink's paint system, through all the layer data structures, through the Chrome compositor, and finally pass it to Viz as metadata along with the render pass for that document. And Viz keeps track of the most recent region capture data for all the crop IDs that currently have been assigned. Finally, when that tab that has the region capture data gets captured, I've kind of alighted the steps where the capturing document actually requests to capture the tab and gets the capture stream. You basically grab the video track from your tab capture stream, and tell it to crop to the crop target, which again you might have gotten from somewhere else, say from the document that set the crop target via post message. Originally, when we first launched region capture, we only assumed that both the captured content and the capturing document were in the same page. Now you can actually do it across tabs or pages, so that's it's a little bit more flexible now. But when the page says crop to the crop target, we pass that information to the tab capture implementation that runs inside the Chrome's compositor Viz. And if that crop ID is valid for that page, then we look up the region capture data that says the most recently laid out region and crop the capture stream to that region before passing it back to the application. And this works really well for the use cases where we've been working on, but was quite tricky to implement because we had to pass this metadata through several layers of the paint and compositing system. And we wanted to be careful and only have the capturing application receive the cropped frames only receive cropped frames. So we need to make sure that all the processes involved agree that the state of the cropping was basically the same. After we kind of built this first region capture feature and launched it, and it's starting to get used in some products, we realized that there could be some circumstances where region capture might not give the best output for the user. So if you region capture a very small region of the page, you actually end up with a pretty small number of pixels in some cases, and text or vector graphics might end up being fairly illegible. So we started working on a follow-up project we called HIDPI capture, where if the application that's doing the capture is requesting frames of a much larger size than the region that's actually being captured, we kind of behind the scenes do some upscaling. The browser recognizes this is the case, and behind the scenes adjusts the device scale factor of the captured page to be higher than it normally would be, so that we can essentially render, say, 1.5 or 2x the number of pixels, so that when we do the capture and the cropping, you end up with something that's much more legible. So the result on the left is a capture of a very small region. On the right, we've enabled high DPI capture. I think this is probably 2x. And you can see the end result is much improved. We're currently kind of refining the heuristics to decide when to activate high DPI capture, what scale factors are going to work best, incorporating real-time performance feedback from the capturer and the application and whatever is receiving the capture, whether that's WebRTC or something else, and planning on rolling this out sometime in 2023. Going back to my comments about improving the efficiency of capture, if you're capturing something that Chrome is rendering, we can try to do a much better, we could try to be more efficient about it as well. Normally when we're in the middle of a tab capture, the kind of capture implementation in the browser issues copy output requests to Viz, and that says, Viz, please make a copy of the frame that's currently being rendered and put it into memory somewhere. The default way this worked was a pool of shared memory that existed between the compositor and the renderer that was responsible for consuming it. However, if you are doing this for very, say, high resolution video, this resulted in a lot of memory bandwidth each time. Also, we would immediately have to read back each frame from the GPU to the CPU, which takes time and power. And we would often have to do a format conversion because it only supported I420, which is 1 pixel format for tab capture. These issues all kind of resulted maybe in dropped frames or maybe a lot of power consumption, and we wanted to try to come up with a more efficient way to do this. Over the last year, we started implementing something we call zero copy capture. We call it zero copy, but really it's 1 copy because you have to make at least 1 copy for people to read from. But the goal is to avoid that early CPU readback and try to keep as much of the frames captured on the GPU as possible, and also avoid any like format conversions that might require extra time and CPU. In this case, we basically keep a pool of GPU memory buffers that can be written to directly to by the compositor. And then if the consumer can also use those frames on the GPU, maybe it's putting them into a canvas or using a hardware video encoder, we might be able to avoid having to copy them to system memory entirely. We've seen some really nice performance improvements when trying to capture from tabs showing high resolution video, and we are starting to roll this out in M104 on Mac and eventually bring it to other Chrome platforms in 2023. The last kind of thing we have in progress is kind of going beyond what we did with region capture. So going back to the idea of semantic capture, capturing really something that's meaningful, we kind of fit it on top of this much broader capture mode, which is capturing everything in your tab. It required a fair amount of complexity to plumb all this metadata around through the Blink compositing and capture systems. What if we could add an even more direct way to capture exactly what the application cares about that avoids some of that complexity? So we're exploring a new mode which allows the capture of arbitrary elements on the page as a media stream, regardless of how they are stacked and positioned in the page. So even if you have something that might be occluded, like the 2 of hearts here, you wouldn't be able to get it with region capture because we only capture exactly what's shown at the final result of rendering the tab. Here we could actually grab a frame that's rendering from that occluded element. In some ways, this is the most powerful version of this real-time semantic capture, as a page could take any part of its document that's meaningful to share in real time with others and turn that into a media stream for either real-time sharing, or in some of the developers we talked to about this, there's a lot of really interesting use cases to basically record animated content basically turn any kind of animated content into a video. for sharing later on social media or what have you, or even some use cases where they want to do regression testing of their website by capturing elements on the page and diffing them between one version and the other. We're currently evaluating routes to a prototype implementation using some of the mechanisms for the shared element or view transitions that have been developed, and in parallel investigating some APIs, permissions, and what is the right consent model for the captured content. There's a WIT-G incubation thread that has some of the early conversations around this. To kind of return to the premise of the talk, it's kind of a false choice, so I don't think it's really one or the other. But links are super important for the web and always will be. But over the last couple of years, we've been working towards giving the web some new capabilities to create user experiences based on just capturing real-time streams of web pages and for multiple documents and combining them together, starting with tab capture, then region capture, and maybe element capture in the future. Pages can be much more targeted about what content they want to have shared, maybe create some new types of applications, increased usability and privacy by not having included content captured if you're capturing elements. It's kind of a third way of composing stuff on the web. So we have links, we have frames or embeds, and now we have kind of real-time streams. And I think could be a lot of interesting possibilities for the future. So just a little bit about who's been doing this work. It's been a work over many, many years. I take credit for only small pieces of it. A slide would be too many. And often these are really great collaborations across web platforms and Blink, including media, which I'm a part of, Paint, compositing, WebRTC. If you're interested in any of the projects or have questions, feel free to contact me directly. Or we have a couple of broader communication channels where folks who work on this stuff hang out. And I'm working on some of these more recent projects like region capture and HIDPI, making public design docs, and they'll be linked from our README page, which is linked below. And that's a QR code with a link to my talk. And I'm happy to take any questions you have. Thank you.
All right, Rob, go ahead.
Yeah, you mentioned at the beginning that a lot of this is motivated from being able to share and collaborate on content. It seems like the next level might be interacting with content that you're seeing on someone else's screen. Has there been any exploration of this?
I think there's been some thoughts, but we haven't really made any concrete explorations. I think we've kind of relied on the application to kind of handle the interactivity part of it in terms of capturing input and making modifications. But I think it would be really interesting to make the real-time sharing much more bi-directional and make it easier for apps to capture input and share it out. You can kind of do that now with WebRTC and data channels, but there's more. The app has a lot to do, so I think it'd be interesting to explore.
Yeah, well, and it works when you own the thing that you're sharing. But if you're sharing like a slideshow from another application that's not part of the sharing environment, then you can't really control it externally.
Yeah, so there is one project I didn't talk about because it isn't. I guess it's kind of within this area, but a little bit different. It's called Capture Handle, and it allows the application doing the capture, being captured, to kind of provide a handle with some metadata to the application doing the capture. And then they can potentially use that to rendezvous and set up a way to communicate and maybe some kind of controls. So one use case would be slide is being captured by some non-Google application, and it wants to allow that to control slide next forward. There's a way you could do that through Capture Handle. So check out Capture Handle, or I can send you information afterwards.
You mentioned view transitions. Can you tell me more? Collaboration with that API?
Yeah, so I had a couple conversations with Kushal, and he believes that some of the mechanisms that were built to enable view transitions, where you can render a part of a document into kind of its own layer, would give us a path to finding that layer in Viz and capturing frames from it. So we haven't gotten too far along in terms of implementation. We just started looking at kind of the details of how that's implemented. But in some of our earlier explorations for doing, say, arbitrary pip windows, also relied on this idea of putting things into their own layer, like a top layer, capturing that and rendering it somewhere else. We think this is maybe an easier way to get to that path, because essentially what we're looking for is something that Viz knows about, that we can capture frames easily from, and what can we plumb into Blink that would allow us to render into that layer or surface.
Dimitri, go ahead.
Can we share FetCM pop-ups through with the body? Like, actually, can we capture iframes?
Yes, with region capture we can. With element capture, I believe it should also be possible, but again, we haven't gotten as far into the implementation yet for me to be 100% certain.
So on the element capture, there are some interesting technical questions there, since the occluded content might not even be painted. But setting those aside, are there user or privacy concerns that you might be sharing some bits that aren't even shown to the user doing the sharing?
So I think there's going to be some thinking about how do we make the user aware that a capture is happening and giving them visibility into what's being captured, because we may again be capturing occluded or off-screen content. This isn't necessarily a new thing, because you can do this now with Canvas and some other elements, but I think there probably will be some thinking about how do we make sure users are aware of exactly what's being captured.
Can you capture browser UI?
So using some of the earlier capture modes I talked about, window capture. Using for example, window capture, we capture either a window from the underlying OS, or if it's on Chrome OS, we capture it from Aura, and that would include all of the browser UI.
So I just wonder whether other browsers are also implementing something similar, and if the features are spec'd out already, how is that in terms of interop and all this?
So Git Display Media, I think, is available in all the major browsers. I don't know off the top of my head which ones have implemented tab capture. Region capture is fairly new, and I don't think has been implemented elsewhere yet. But I can get back to you with that information. All right, thank you very much, and I'm happy to chat with anyone afterwards.